Welcome to this explainer, everyone. You know, if you've ever stepped foot on a bustling construction site, you already know that the moments right before a concrete pour, well, they're absolutely critical. Today, I'm going to walk you through something that might seem like a minor detail to an outsider, but is actually the absolute backbone of a structure's lifespan: cover block and concrete cover checking. Whether you're a civil engineering student, a fresh site engineer, a supervisor, or even a non-technical person who just wants to understand how quality construction actually works, consider this your practical site masterclass. We're going straight into the real site conditions today to make sure you know exactly what to look for before those concrete trucks arrive.
Okay, let's dive into this. Here is our roadmap for today. First, concrete cover basics. Second, why pre-pour checking matters. Third, drawings and IS codes. Fourth, step-by-step site checks. Fifth, common mistakes in pouring. And finally, number 6, the final pre-pour checklist.
All right, Section 1, Concrete Cover Basics, the protective skin.
Let's get our basic definition straight right out of the gate. Think of the steel reinforcement like the skeleton of your structure. The concrete cover? That's the protective skin around that skeleton. Now, there's a crucial technical difference here that you need to know. On the left side, you'll see the concrete cover. That's the actual required physical gap, the protective concrete layer between the steel and the outside environment. On the right, we have the cover block. This is our physical tool, the little spacer we actually place on site to guarantee that required gap stays open during the fixing and the pour. Basically, we check the blocks to ensure the cover. It's really as simple as that.
Moving on to Section 2, why pre-pour checking matters, preventing disasters.
Now, why are we so obsessed with this? Because ignoring cover blocks triggers a literal disaster, and this brilliantly illustrates exactly what happens. Imagine a stirrup touches the shuttering. Step 1, the steel is exposed. Step 2, after a little while, moisture and oxygen sneak right into that thin concrete. Step 3, that steel starts rusting. And here's the real danger, guys. Rust expands. It actually takes up way more volume than the original steel. So step 4, that outward pressure bursts the concrete open from the inside out, causing cracks, ugly rust marks, and eventually spalling, where chunks of concrete just fall right off.
That exact chain reaction is why I constantly remind junior engineers of this golden rule. Cover is not just a small gap. Cover is a durability requirement. This isn't just about passing today's visual inspection, it's about making sure the whole building doesn't need massive, expensive repairs 5 or 10 years down the line. A bad cover might look fine today, but it's a ticking time bomb inside your concrete.
Which brings us to Section 3, Drawings and IS Codes, the rulebook.
Look, before we even put our safety boots on and grab a measuring tape, our job actually starts right here, at the drawing board. First things first, you have to open the latest approved structural drawing. Then, verify the project specifications, the quality assurance plan, and the method statement. And let me clear up a very common, very lazy site habit right now. Do not assume one fixed cover value for every single RCC member. No way. The cover for a footing is totally different from a column, which is different from a slab or water tank. It depends on the member, the bar diameter, and the design. You absolutely must read the specific drawing notes.
Now, beyond the specific project drawings, we also have our ultimate guiding light here in India, the Indian Standard IS 456-2000 code. This code lays down the absolute baseline requirements for nominal cover based on durability, exposure conditions, and fire resistance. Remember, your final cover on site must always follow both this IS code and your consultant's specific instructions.
Now, what's really interesting about this slide is how clearly Table 16 of the IS 456 code links the harshness of the environment with the required thickness of our protective cover. Take a look at this. If your concrete is in a mild exposure condition, you just need 20 millimeters. But if it's facing an extreme condition, say it's exposed to aggressive chemicals or severe weather, that nominal cover jumps all the way up to 75 millimeters. The harsher the environment, the thicker the skin your steel skeleton needs. All right, let's head out to the site. Section 4, Step-by-Step Site Checks, the walkthrough. Let's move to the actual site and see how this builds into our daily routine. Time to check the shuttering and the steel systematically. Step 1, check the bottom cover. Look at your footings, your rafts, your slabs. The bottom steel must never ever rest directly on the PCC or the soil. Step 2, check the side cover. For your beams, walls, and columns, make sure those stirrups and main bars aren't touching the side shuttering at all. And Step 3, check the top cover. For slabs or tanks, verify that the top steel reinforcement is exactly at the correct level and heavily supported.
So, what exactly are we looking for when we inspect these blocks? Well, first, the size has to match the required cover from the drawing perfectly. Second, the material. Only use approved stuff like concrete of adequate strength, mortar, or approved PVC. Third is spacing. IS 456 guidance recommends a maximum spacing of 1 meter to keep that heavy steel cage from sagging. Fourth, tie them securely with binding wire so they don't pop off. And finally, you've got to provide strong chairs, those zigzag support bars, to hold up that top steel.
Okay, here's a tricky question that catches a lot of fresh engineers off guard. You've checked the cover, everything looks flawless. But what happens to that cover after the shuttering is finally closed up by the carpenters?
Well, the reality is, it often changes. You have to recheck it after the final shuttering closure. When carpenters are hammering away, tightening tie rods, pulling things into alignment, that reinforcement frequently gets shoved or pressed right up against the formwork. A perfect pre-check is completely useless if the steel gets moved out of place right before the pour. Always double-check once the formwork is locked tight.
Moving on to Section 5, Common Mistakes in Pouring, Site Realities.
Let's talk about the real world and the incredibly frustrating things you'll actually see on Indian construction sites if you aren't paying close attention. These bad habits are everywhere. Missing blocks or using the wrong size entirely, especially on beam sites. And number 2, this one drives me absolutely crazy. Using broken floor tiles, brick pieces, or random stones as cover blocks. Just no, never allow this. We also see steel touching the shuttering, weak chairs bending under the weight of workers, and footing steel sitting right on the PCC. Oh, and no photo records. Guys, if you don't take a photo before the pour, you have zero proof that the cover was correct when those hidden defects mysteriously show up later.
So, the crucial point is this. Your job as a site engineer is absolutely not done the minute you approve the pour. You have to monitor that cage during the concrete pouring itself. Workers are going to step on the steel, which can bend chairs and sink the top mesh. The sheer pressure of wet concrete can shift the whole cage. And the vibrator nozzle, that thing can easily knock blocks loose or push the flexible steel right against the shuttering, destroying the side cover you just carefully checked. Keep your eyes peeled while that concrete is flowing.
Finally, Section 6, Final Pre-Pour Checklist, the sign-off.
All right, we've studied the drawings, we've walked the site, we've corrected the mistakes. Now let's formalize the approval. Before you give the final green light, run through this administrative finish. 1. Reinforcement is totally clear of the shuttering. 2. Blocks are tied securely. Nothing is loose. 3. Vibration access is clear so the needle won't get stuck in the steel cage. 4. All QA/QC checklists are officially filled and signed. 5. Clear photo records are saved. And 6. The pour card and daily progress report, the DPR, are properly updated. Boom! Good cover means better durability and better concrete quality. Period. You're ready.
So before we wrap up, I want you to ask yourself, is saving 5 minutes by skipping a cover check today really worth risking a massive, catastrophic structural failure 5 years from now? Cover block checking is not a small activity. It protects reinforcement and improves concrete durability. For detailed PDF guide and more practical civil engineering information, join our Telegram channel and WhatsApp civil engineering community. Links are in YouTube description and pinned comment. If you have doubts, comment below. IBG&I will reply. By IBG&I's Civil Workflows.